Hi guys, Mayang Adlaw. Welcome back to my channel. For this video, I will be presenting to you about future value, present value, and compound interest. This is just more on the manipulation of the formula. I will just be presenting to you the application of compound interest in my next video, which is about problem solving. So for the lesson objective, at the end of this video, you should be able to solve for future value, present value, and the compound interest. This lesson requires us a prior knowledge on the following: illustrating simple interest and solving for the principal, rate, time, and simple interest, or the problems involving simple interest. So before we proceed to the examples, let us be acquainted with these formulas first. So we have four formulas here. The first formula is for the future value for multiple compounding periods. That means we will be using this formula if the given compounding period is multiple. That means the amount is compounded more than once a year. That means semi-annually, quarterly, or monthly. The second formula is still for the future value, but this is for annual compounding periods. This means that the amount is compounded once a year, per annum, or yearly. That means once a year. And the third formula is on the present value for annual compounding period. How about for the present value for multiple compounding periods? We will just be using this formula for the present value for multiple compounding periods. I will be presenting an example later about finding the present value for multiple compounding period. And lastly is the compound interest. That means I sub C, compound interest, that is the future value minus the present value. So here, the FV here is for the future value, the PV is for the present value, the R is for the rate, N is for the number of compounding periods. Is it monthly, quarterly, or semi-annually? And of course, the T is time in years. So we will be manipulating this formula in our examples later. So let's proceed to our examples. For example, we are given the present value of 410,000. Our rate is 0.8%, or that is in decimal is 0.008. Then our time is 6 years. Then the N is quarterly. When we say quarterly, that means the amount is compounded 4 times a year. That means quarterly, that is every 3 months. So meaning when we say quarterly, our N here is equal to 4 because the amount is compounded 4 times a year. Then we will solve for the future value and the compound interest. If we are going to analyze the given, our N, the number of compounding period is quarterly. That means this is multiple compounding period. That means we will be using this formula for the future value, the first formula. The future value is equal to the present value times 1 plus the R over N quantity raised to NT. That means the number of compounding periods multiplied to the number of years. So what we need to do here is just simply substitute the values to this formula to solve for the future value. By the way, we cannot solve for the compound interest without solving first for the future value, because compound interest is future value minus the present value. We already have the present value, but we do not have the future value. So we need to solve first for the future value before we can solve for the compound interest. So to solve for the future value, we substitute these values to the formula. So we will have the present value is equal to 410,000 times the one which is the constant, plus our R is 0.008 over the N, which is quarterly, so our N is 4. Then raised to the N, which is 4 times the time, which is 6 years. Then we will simplify. We divide 0.008 divided by 4, and we multiply 4 times 6. So the result would be we copy 410,000 times 1 plus 0.008 over 4 is 0.002. Then quantity raised to 4 times 6 is 24. Next is we add, of course, we add 1 plus 0.002 that give us 1.002. Then we raise this number to 24. By using your calculator, 1.002 raised to 24 will give us 1.0491. We just simply copy the present value, which is 410,000. And of course, lastly, we multiply 410,000 times 1.0491. That would give us 430,131. So therefore, this is our future value for the present value 410,000 with an interest rate of 0.8% within 6 years compounded quarterly. So the future value would be 430,131. Now next is we need to solve for the compound interest. The compound interest is the future value minus the present value. So we already have the future value which is 430,131. Then minus the present value which is 410,000. So that would give us our compound interest is 20,131. Meaning this is the interest gain all throughout 6 years with an interest rate of 0.8% compounded quarterly. Let's proceed to example number 2. This time we are given the future value of 98,170. Our rate is 4.3% or in decimal that is 0.043. Then our time is in years, 4 years. And this time, our N is annual, meaning once a year, meaning single compounding period within a year, so once a year. Then we need to solve for the present value and of course the compound interest. Now first things first, we need to evaluate our N, the number of compounding period. This time our N is annual, that means once a year, so our N is equal to 1. So single compounding period within a year, so we will use this formula. The present value, this is now the third formula. Finding the present value is equal to the future value times 1 plus the rate quantity raised to negative t. So if our N is 1, so that means R over 1 or R. The same also with NT. When we say if N is 1, 1 times t is t. So therefore, that's why we do not have the N anymore here. So this time we substitute the value. The present value is unknown. The future value is 98,170. And our rate is 0.043 and our T is 4 years. So we substitute, this would be our equation. The present value is equal to 98,170 times the 1 plus the R is 0.043 and our T is 4, so that is negative T, so this becomes negative 4. This time we add 1 plus 0.043, so that gives us 1.043. So we just simply copy the future value, which is 98,170. Then we raise this number to negative 4. So using your calculator, 1.043 raised to negative 4 will give us 0.8450. Then multiply this number to the future value, which is 98,170. That would give us 82,953.65. So this is now our present value. So as you can see, the present value the present value should always be less than the future value. And vice versa, the future value should always be greater than the present value because the future value already carries the compound interest. Now to solve for the compound interest, so we have the future value which is 98,170 minus the present value which is 82,953.65. So our compound interest is 15,216.35. This is the interest gain for the investment of the present value, which is 82,953.65, and the interest rate of 4.3% within 4 years compounded once a year, meaning annually or yearly or per annum. Now let's proceed to example number 3. For example, we are given the future value of 7,500 and our rate is 3.7% or 0.037 and our time is 9 years. Then our N is semi-annual. That means semi-annual twice a year. So this is multiple compounding period. We need to solve for the present value. Since this is multiple compounding period, so our formula to use here is the first formula. The future value is equal to the present value times 1 plus the r over the n quantity raised to nt. So we substitute these values to the formula. So we will have this time, since the unknown is the present value and we are given the future value, so we will substitute the future value, which is 7,500, and since PV is unknown, so we'll just simply write there PV, which is the unknown, times 1 plus our R is 0.037 over N is 2. Why is this 2? Because this is semi-annual. So N is 2. That means the amount is compounded twice a year. Then quantity raised to 2 times 9. Our time in years is 9. Then we simplify. We divide 0.037 by 2 and multiply 2.9. So the result, we simply copy 7,500 is equal to the present value times 0.037 divided by 2 is 0.0185. Then 2 times 9 is 18. Then we add, that would give us 1.0185. Then we raise this number to 18 by using our calculator. That would give us, this would give us 1.391. So we copy 7,500 is equal to the present value is unknown. Then 1.0185 raised to 18 is 1.39. Then this time, so to eliminate 1.391, since we are only going to solve for the present value, we need to divide both sides by this number. So the present value times 1.391 divided by 1.391, since we divided this number to the right side of the equation, we will also divide this same number to the left side of the equation. This time, we can cancel out 1.391. What remains on the right side of the equation will be the present value. Then 7,500 divided by 1.391 will give us 5,391.80. So the present value is 5,391.80. Now let's proceed to example number 4, the last example. For example, we are given this present value of 1,500. This time, our rate is 5.2% or that is 0.052. Then our time is 10 months. As you can see, the time is 10 months and our T is in years. So how do we go over with this one? Later I will be showing you how to convert 10 months to years. And our N, the number of compounding period is annual. So that means once a year. Then we need to solve for the FV. Now since annual once a year, so we will be using this formula, the shorter one. So FV, or the future value, is equal to the P, which is the present value which is given, times 1 plus the R, which is 0.052, and our T is 10 months. Now this time, how do we convert 10 months to years, since we cannot substitute 10 months here to the formula because this is in months, and in the formula, our T is in years. So we need to convert 10 months to years. So how do we convert 10 months to years? We just simply divide 10 months divided by 12 because there are 12 months in 1 year. So to convert 10 months in years, we just simply divide 10 divided by 12. So this time, this will become, we substitute these values. Our PV is 1,500 times the constant one plus the R is 0.052. Then we raise this one to, using your calculator, 10 divided by 12 is 0.833. approximately 0.833. So we will not do not substitute the 10 in the formula because the t in the formula is in years, but our given here is in months. So we need to convert first 10 months to years before we substitute to the formula. So 10 divided by 12 is 0.833. So that gives us 1.052. Then we raise this number to 0.833. So we copy 1,500 and 1.052 raised to 0.833. That will give us 1.0431. Then we multiply this number to the present value, which is 1,500. That would give us 1,564.65. So the future value for the present value of 1,500 is 1,564.65. This is if the interest rate is 5.2% and compounded annually, but the time is only 10 months. Okay? So meaning still the amount gains an interest of 64.65 even if the amount did not reach the 1 year compounding period. So 10 months rasya po to. Okay, so that's it. I hope you have learned something about this video. And next video is on the application on compound interest. It's about problem solving involving the future value, the present value, the compound interest. That would be for the next video. Thank you and God bless.